Okay, today we're going to talk about Objective 9, demonstrate an understanding of percents, proportional relationships, probability, and statistics in application problems. So first problem, number 42. The energy of a certain particle is 3.86 joules. If this particle loses 0.105 joule of energy every 30 seconds, what will its energy be after 8 minutes? So there are several ways of working out this problem. There's a couple ways to work it. We could set up a t-chart. I don't know if I'll go through the whole process. I think you'll catch on to what I'm trying to do here. If at 0 minutes, or when we start, there is 3.86 joules, then 30 seconds later we reduce that by 0.105 joules. So 3.86 minus 0.105, and now I have 3.755 joules remaining. Then at 60 seconds I'll need to subtract another 0.105, and I have 3.65 remaining. At 90 seconds, subtract another 0.105, and I have 3.545. So I could continue this process and get all the way down to, well, if I have 8 minutes, how many 30 seconds are in that 8 minutes? So I know that in each minute I have 2 sets of 30 seconds. So that in 8 minutes I should have 8 times 2 sets of 30 seconds, which gives me 16. So I would need to do this all the way down here 16 times. So what I need to do is I need to subtract the 0.105 16 times. So I could write an expression or a number sentence like this: 3.86 minus 16 times 0.105. And this would be the shortcut that I would have to go through this entire process and get all the way down here to 480 seconds, I believe. So what I'm going to do is I'm going to go the shortcut. If you feel better with the t-chart and would like to do this process right here, if it feels better to you, then do so. So what I have here is 3.86 minus, and these brackets here are just a secondary set of parentheses. So I have 16 times 0.105, close, close, and I get 2.18. So at the end of the whole thing, I'll end up with F 2.18 joules. Moving on to number 34. The Hawthorne Mustangs have won 4 games and lost 6 games this season. Based on these results, which is the best prediction of the number of games the Mustangs must play in order to win 6 games? So this is a proportion problem. Basically, we're given that they won 4 games, they lost 6. So what that means is they've won 4 out of playing 10 total games. And they want to know how many games do they need to play in order to win 6. Well, we have our wins on top on this side, and we have our total on bottom on this side. So what I need to do is I need to put my wins on top on this side in my proportion. So I want to win 6 games. So it goes there, and I'm looking for which is the best prediction of the number of games. So I'm looking for the total number of games that I'm going to have to play. So that'll be represented as x. And as solving a normal proportion, we cross multiply. And we get 4 times x is equal to 6 times 10, which is 60. Divide by 4 to solve for x. And we get that x is equal to 15. Now the most important thing when you're setting up your proportion is this. If I have wins on top on this side and I have total on bottom on this side, then I must have wins on top on this side and total on bottom on this side. I could flip that around and have total on top and wins on bottom. That's no problem. Just make sure on the other side it's set up the same way. Number 23. Last Friday, a used car dealer had cars for sale for $600, $690, $695, $710, $725, $750, $850, $995, $995, $995, and $1495. Select the most effective measure to use to convince potential customers that the dealer's prices are very low. So we have these what we call measures of central tendency. We have mean, median, mode, and range. Remember, mean is the same as average, where you add them all up and divide by how many you have. Median is the one in the middle when you list them in order from least to greatest. Mode is the one that is listed the most. And range is the difference between the max and the min. So let's look at our numbers here. We have, seems like lots of prices here that are somewhat comparable. I mean, from $995 to $600, there's only $395 difference. So all of these prices here are pretty tight. Now, when we do get to this number here, $14.95, that's quite a bit higher than the rest. So we don't need to know this for this problem, but for your information, that $14.95 would be an outlier. It's just it's one of the numbers that is way outside of the range of most of the other data. So if I'm trying to convince all of my potential customers that I have low prices, I probably do not want to do mean, because if I average all these together, this outlier right here is going to make my average be higher than it. Then see, most of these prices here are relatively the same. So if I end up selling this one car right here, this one, that's higher, then all of these are going to be relatively close. And if I average just these smaller numbers here, then if all of my numbers were tight together like these smaller ones, the mean would probably be the best way to go, because I can average between all of these low prices and that would give me a good idea. But this outlier right here is going to cause my mean to be high. To be higher actually than most of the other numbers. Okay, so mean's not going to be the way to go. Mode is not going to be the way to go either, because of the fact that just because you may have 15 cars for sale and every one of them is over $20,000 except for 2 of them, which are $500 a piece. And if all of the other car prices are different prices over $20,000, then my mode would be $500 a piece, and that would be misleading. So the mode is not really going to tell you either. And even in this case, our mode is $995. So it's our highest price car, not counting the $14.95. The mode is going to be our highest price car, so that wouldn't make sense either, because we're trying to convince of low prices. The median is not going to work because of the fact that the difference between the highest price car and the lowest price car, the range is not going to work. D would be range, because if I take the highest price and subtract the lowest price, that doesn't give me any kind of indication what most of the other cars' prices are going to be. Now let's examine median because it is going to be our correct answer. All of our numbers here are already, looks like our prices are already listed in order from least to greatest. So if I start trying to find my median, I would knock off the highest, then the lowest, next highest, next lowest, next highest, next lowest, and so on until I come to the median, which is 750. Notice that this number is very, it tells you, it gives you the better picture of what most of the prices of the cars are for. So this outlier is going to cause the mean to be too high. Mode doesn't make sense and range doesn't make sense. So median is going to be the best bet in trying to convince customers that we have the lowest price. Number 53. The manager of the sherbet shop wants to construct a circle graph showing the popularity of the various sherbet flavors he offers. Here is the tally of the favorite flavors of his first 30 customers on Saturday. So we have favorite sherbet flavors, pineapple, lime, lemon, raspberry, and orange, and all of these tick marks as far as which one are the most favorite. It says in the circle graph, which proportion can be used to find the number of degrees in the sector for an orange sherbet? What you have to know here is when we're talking about a circle, because we're wanting to do a circle graph. In a circle, there are 360 degrees of revolution. So if I'm looking for which proportion can be used to find the number of degrees for orange sherbet, I would have to make a proportion. And I'm going to use this information about 360 degrees being in a circle. So I have 10 people that say orange is their favorite. 10 out of a total of 30 customers. So 10 out of 30 is equal to, now here I have, as I was saying before, you have to be careful what you put on top and on bottom. I have my part on top and I have the total on bottom. So if I have that set up this way on the left side of my proportion, on the right side I have to do it the same way. The total in degrees of the circle is going to be 360, so that must go on bottom. The amount of degrees covered by the sector, however big that's going to be, that like orange, it's going to look like a piece of pie. Then I'm going to have that part, this part of the sector of the entire circle on top. So part, total, and the answer is going to be D.